This is Prashant. So we are working on leaf disease diagnosing using Python. So myself, Prashant, and Jashwant and Madhu, we are three people working on this project. So now I'm going to explain about the project. So the next one, the outline. So in the outline, we have introduction. So we had done the introduction part in the introduction and the background, project observatives, and data collection. We had collected the data. We have almost collected a number of images, and also the methodology and the results, observation and discussion and reference. So we had taken a lot of references. So these are the things we are going to explain in this PPT. So the first one, the introduction part. So as the world population is increasing, food production must be increased. So along with the improvements of different crop types, detecting of diseases through an important goal for achieving food security. So plants are most affected by biotic agents which causing diseases on their leaves, fruits and stems. So diagnosing and detecting of disease should be done in early stage and the accurately otherwise, it decreases both the quality and productivity of the agriculture products. So once the disease caused to the plants, it if we delay to detect the disease, so it going to waste the whole crop. So that's the reason this program will help us to easily identify the disease in the early stages. So let me explain the background. The next slide. So the old method of identifying plants diseases releases on the physical presence. So the old methods they are used based on the knowledge based. So by watching the plant, so it going to delay the process. So the detecting process is taking very delay. So at that time, the whole crop going to be wasted. So evaluator may become tight, suspectable, and various illnesses and loss attention, reducing accuracy. So once the disease is caused to the plants, so detecting in early stages, it will help the farmers to get high productivity to and also to ensure the quality. Multiple coaching sessions are required and traditional process are necessary and significant of amount of time and effort. So by this program, it will helpful to easily detect the disease and the health status of the plant. So by that, everyone can easily identify the disease and take the necessary steps to prevent that one. So I'm going to the next slide. So project observation. So one of the most serious risk to agriculture sector is disease transmission to healthy plants. So the healthy plants will be affected by the non-healthy plants as well. So if we the detect disease detection is done in the final stage. So by this program, we can easily detect the disease in the early stages. So if the diseases are not detected in early stages, they can spread rapidly and infect the entire farm. So plant disease detection technology helps in the early detection of sick plants and assign the using scaling plant disease detection to range of plants in cost effective manner. So it also decreases the productivity and loss of farming. So the goal of this project is to easily identify the disease to prevent the health of the plants. So the goal of the study is to using CNN. So it is a neural network to identify the diseases. It is a machine learning like language used to detect the images. So that is the reason we have used this one. So the next, the data collection. So from the plant village dataset, we have gathered 6,000 images of good and unhealthy leaves. So this part is going to explain by the Jashwant. So I'm handovering this part to the Jashwant. So Jashwant will explain on data collection. So I'm handovering to Jashwant.
Hello, this is Jason. I am continuing from the data collection. So from the data collection, we have gathered 6,000 images of good and unhealthy leaves. So that is divided into 4 categories. So it's named as the healthy leaves, and one is the bacterial spot, the yellow leaf curly virus, and the last one is the lead blight. So to identify this, the leaf sickness, we have divided into 2 parts. One is with the 75% being used for training, and the other for testing. The other part is for testing. So next, moving to the next slide, this is a methodology. So for this project, we have used a conventional neural network method, that is a CNN. It's a type of artificial neural network used in image recognition processing that is specially used designed to process pixel data. So the neural networks are distinguished from other neural networks by their superior performance with their image, the speech, or audio signal inputs. So they have four main types of layers, which are the conventional layer, and is the ReLU layer, that's a rectifier unit layer, and the pooling layer, and the last one is fully connected layers. What is the conventional layer? The conventional layer is the main building block of a CNN. Uh, it contains the set of filters or kernel parameters of which are being learned throughout the training. For the size of the input image should be like 5 by 5, the 7 by 7, or any other size which is pixels range from 0 comma 1. The size of the filter is usually smaller than the actual image. The next one is the ReLU layer. That's a rectified linear unit. There's a convolutional procedure continued to the ReLU layer. It improves the non-linearity of the image that contains edges, borders, and colors. Using the ReLU layer function, we set the negative integers into activation map, which is conventional output to 0. That's a pooling reduce the size of image. The next method is called pooling one. The pooling is a method of reducing the number of parameters and the calculations that must be performed. So we used the pooling on a pooled feature map to divide the output, the rectified layer unit, into the overlapping sections as an output. So this layer generates a pooled feature map with fewer parameters. And the last one is the connection layer. That's a few connection layer. In the connection layer, the artificial neural network is introduced to our CNN to combat features and the qualities to improve the accuracy. So during this phase, the error is determined and back propagated. The weights are adjusted to reduce inaccuracy. An improper model are adjusted to reduce accuracy and the performance. And back and forward propagation are carried out until the data set is accuracy or error free. Then I can moving to next slide. From here onwards, my friend will continue the Madhu.
Hey, hi. So coming result, before explaining the result, I'll just explain about this one, plant detection thing. Before that, we need to open IDLE. This is the where environment we run .py files. Let me open that .py file. So this is the we programmed a simple desktop application by using a Python program. So after running this module, we land in a application where we can select the images. Those images are already trained images. We have like almost 6,000 images we trained. Here, like you can see the test. This can be found in open. We found in open sources. Where like we have so many of sample data. So let me select this one and open this file, and will detect this disease. Here, CNN comes in the picture. So what's happening is by after detecting, the CNN architecture carries out analysis and returns the status, whether it is healthy or non-healthy. So yeah, status is unhealthy. Disease name is lead blight. And even we can see the remedies also. If you click on this thing, yeah, we can see the remedies for lead blight. Even we can modify this also if you want in programming. And let me run for unhealthy. Sorry, like there was a small, accidentally I closed that one. After this run, we used to like, we land in the landing page. It takes some time. Yeah, same only, but here I'm just selecting the healthy leaf, which will tells us the its status. It's a unhealthy only, bacterial spot. Yeah, like this we can say, if we select a healthy leaf, it will tells us like healthy. Come back to PPT. If I come back to PPT like this, so if it is unhealthy, here also I'm just selecting as unhealthy for the remedies. And why we are like CNN matrix is, the CNN model has almost like 96% of accuracy with this thing. And these all the accuracies for CNN matrix, precision and recall, and F1 score. It's has the highest accuracy. And like even we can train. We already trained and executed. So for this one, prediction and losses also there. So coming back to this one, observations and discussions. So this trained images has as already we discussed, it's almost like a 96% of accuracy when verified with controlled environment. Yeah, that's why we have a CNN model in this project to detect the diseases for leaves. And so we took like these things from these references